Okay, today's homework solution video is going to be a little different than any of the ones I've done before. I'm using this interactive screen here. Never done a video on this before. Have no idea how this is going to turn out. The room that I usually use to do my videos is occupied today, so I'm going to go ahead and try this out. First of all, we're going to be covering 2.5 chain rule, and I just want to remind you what the chain rule says. If you have a function, and well, actually two functions, and you have compositions. So the g function is O. Okay. If the g function is being plugged into the f function, and you want to take the derivative, what you do is you take the derivative of the outer function, which is the f function, and once you take its derivative, you plug in the g function inside of it without a derivative, and then you multiply, this is the chain part, you multiply times the derivative of the g function. So let's start off with number one. So for number one, we have y is equal to the cube root of 1 plus 4x. So I'm going to take this one really slow. What we want to realize is that you have a function inside of another function. So the inner function here is 1 plus 4x. The outer function here is the cube root of x. So, I mean, the cube root function. So if I were to write this out, I could rewrite this as y is f with some g function plugged inside of it. And there we go. I think I can switch back and forth between colors here. Let me try this. Yeah, I can. Oh. But it's smaller. Okay. Anyways, all right, let's just do this back here. So what is the f function here? The f function is the outer function. So I could say that f of x is the cube root of x. And then the g function, yeah, I don't like that. It doesn't make it bigger. I don't know how that's going to come out on camera. So the g function, g of x, is equal to 1 plus 4x. So if I take g and I plug it in right here, then I would get back the original function. So now I'm just going to write out what the derivative should be. Y prime should be this right here. So what I need to do is I need to take the derivative of f and then plug g into it. Why don't I try and do that right here? What is the derivative of f? The derivative of f is, I'm going to run out of room here. It's going to be 1/3 x to the negative 2/3. Right, so I'm just rewriting this as x to the 1/3 power, popping the 1/3 out, subtracting 1 from 1/3, and that's what I get. At the same time, let me go ahead and get the g derivative. I'll put that up here. G prime of x is equal to, this is a pretty clean one, derivative of this is just 4. All right, so now let's go to the formula. I want to take the derivative of f and plug g into it. So here's a derivative of f right here. So it's going to be 1/3 and then x to the negative 2/3. But instead of plugging in x, I'm plugging in g. So g is 1 plus 4x. Okay, so what I have is 1/3 times g, 1 plus 4x raised to negative 2/3. So I've done this part, then times g prime, which is 4. That's it. So this should be equal to, I can multiply the 4 out to the front, 4/3 times 1 plus 4x raised to the negative 2/3. Right there. All right. I wonder if there's a quick way to clear the whole board. Let's see. Maybe a new page? No. Here we go. All right, so let's look at number 2. Oh man, that's going to be really a pain in the butt. Let's look at number 3. Whoa. No, I'm supposed to do number 5. So 5 is y equals square root sine x. All right, so for this, why is that there? Technology, I tell you. All right, so we have an outer function, inner function. I'm not going to use colors this time. The outer function is the square root of x. The inner function is just sine x. So I know for the chain rule I'm going to need the derivative of each one. So the derivative of this one is 1 over 2 root x. Sorry, that 1 is on the top of both of those. And then of course the derivative of sine is cosine x. So this derivative should be the derivative of the outer function, which is this, but with g of x plugged in, and then times the derivative of g of x. So I'm just writing down the formula. So the derivative of f right here, whoa, I can move things around. Just messing around now. Derivative of f, but instead of plugging in x, I'm going to plug in g. So I'm going to take g right here and plug it right in there. So I get 1 over 2 root, but g is sine x, then times the derivative of g is cosine x. And you could just slide that on top and be done. That's it. Okay, next one, number 6. 6 is a little different because you have y equals sine of root x. This is very similar to the previous problem, except that the root is inside. It's the argument of the function. So the outer function is sine x, and the inner function is root x. And so I'm going to need the derivatives of each of these. The derivative of f is cosine x, and then the derivative of g is 1 over 2 root x, like that. So y prime will be f prime, but with g plugged in, times g prime. All right, so that should be the derivative of f, which is this, but instead of plugging in x, I'm going to plug in g. So I'm going to take this and replace that x with this right here. So I'm going to have cosine of root x, I don't need the parentheses, times now the derivative of g, which is 1 over 2 root x. And the most you could do here to clean up would just be put the cosine root x on top, and on the bottom just put 2 root x. And just remember, you cannot cancel those because this is in the argument of the cosine function, so that would be it. All right, number 7. I hope this video comes out okay. I'll be very frustrated if it doesn't. F of x, capital F of x equals the quantity x to the 4th plus 3x squared minus 2 raised to the 5th power. So the inner function that we have here is this polynomial, and then the outer function is this power function. So I'm going to, hold on, I got something on there. I'm going to write down what f and g are over here. F is the outer function. It's x to the 5th. And then g is the inside function, which is the polynomial, x to the 4th. God, that's freaking me out. I wonder if I can turn the volume down at least. Yeah, there we go. All right, x to the 4th plus 3x squared minus 2. I'm just going to look at this camera real quick. Looks like that's going to come out. All right, so let me find these derivatives real quick. The derivative of f is 5x to the 4th, and then the derivative of g is 4x cubed plus 6x. All right, now from here, I just apply the formula. The derivative of capital F of x will be equal to little f's derivative, that's the outer function, evaluated at g, so plug g into it, times the derivative of g. And the derivative of f was this, but we're going to plug into it g. So I'm going to replace that x with all of g. So I'm going to have a 5 in front. Now here comes, this is going to be g, so it's going to be all of this, x to the 4th plus 3x squared minus 2, all of that to the 4th power. Right, so there's your 5, and then g's right there, and then to the 4th. But then I say times g prime, which is this right here. And because it's 2 terms, I must have it in parentheses because I'm multiplying it. Right there, just like that. Now you could move this out to the front, and you could even distribute a 5 through, but that's just algebra. So there's your derivative. All right, let's look at, remember, try and get your answers to look like the answers in the back of the book. So that might require some simplification, some algebra. Another one, capital F of x equals 4x minus x squared raised to the 100th power. All right, so we have an inner and an outer function. The outer function is f of x equals x to the 100th power. The inner function is the polynomial 4x minus x squared. So the derivative of f is 100 x to the 99, and the derivative of g is 4 minus 2x. And so when I go to take this derivative, capital F prime, I'm going to try not to write the formula down right now. It's going to be f prime with g plugged in. So it's this right here with g plugged in. So it's 100, but instead of x, I plug in g. So 4x minus x squared raised to the 99. Then times the derivative of g, which was the thing inside. So that's just 4 minus 2x. 2 terms, so make sure you put it in parentheses. Just like that. There we go. This ain't so bad. As long as it's coming out on video, I'll be happy. I think what I'll do right now is I'm going to go back and look at these. And I'm going to try and do the problems we just did using the shortcut, not the shortcut, but the faster method, which is one I'll talk about in class. But if you have trouble with the shorter method, just follow what I've been doing and you should be okay. So let me just look at the first three we did, and then I'll do the other two. So the faster way to do this, and where you want to get with this eventually, is to just be able to do it without writing anything down. So first I'm going to realize that this, let me get my eraser. This right here is actually the same as that raised to the 1/3. And then what I'm going to do is I'm going to say, all right, what's the outer function? The outer function is I have something to the 1/3. Something to the 1/3, so I cover that up. So what is the derivative of my hand to the 1/3? Well, it's 1/3 times my hand to the negative 2/3. Uh-oh. Whoa. What happened there? Freaked out on me. Negative 2/3. And my hand was the 1 plus 4x. Then chain rule says times, now go inside. We've already done the 1/3 coming out, so I've done that. Now take the derivative of what's in here, which is just 4. And we're done. Here, this one, same thing. I look for the outer function, it's the square root. So I have square root of my hand. What is the derivative of square root of my hand? It's 1/2 square roots of whatever was there. My hand was sine x. So I'm done. Times, now I go inside. I've already done the square root, and I take the derivative of what was inside. Derivative of sine x is cosine x. That's the same answer we had earlier. This one, the outer function is actually sine. So I have sine of my fist. What's the derivative of sine of a fist? It's cosine of a fist, but the fist was root x. Then times, chain rule, we've done the sine, go inside, take derivative of what was there. Derivative of square root of x is 1/2 root x. That. Let me just check something here. Okay. All right, so those are the problems we just did, but faster. Let me do the other two quickly. We had capital F of x equals x to the 4th plus 3x squared minus 2 all to the 5th power. So the derivative of this will be, again, I'm going to go kind of quick here. So what I realize, I have an inner function and an outer function. So the question is, here's a piece of paper. What's the derivative of a piece of paper to the 5th power? Well, the 5 comes out, right, because we're using power rule. 5 times the piece of paper to the 4th. And the piece of paper was x to the 4th plus 3x squared minus 2. So we've done the derivative of the power here. Now we take the derivative of what's inside and tack it on. So derivative of what's inside is 4x cubed plus 6x. That's it. And I'll skip the other one because it's very much like that. Number 8 was almost exactly the same as that, so I won't even bother. All right, number 11. We have f of z equals 1/, z squared plus 1. Now, you could do the quotient rule on this problem, all right? You could do the quotient rule. There's nothing wrong with that. However, I would like us to realize that this is really z squared plus 1 to the negative 1, right? That's what that is. Just bring the whole thing up, put a negative exponent on it. That means drop it down, so it's the same expression. So now if I go to take the derivative, and I'm going to start doing these faster now with the shortcut. I have an outer function here. The outer function is that I'm raising something to the negative 1. So I've got my hand here raised to the negative 1. What's the derivative of my hand to the negative 1? Well, it's going to be the negative 1 comes out. It'll be my hand, and then I subtract 1, so negative 2. Now my hand was z squared plus 1. So I now say times, I've already done the negative 1 power, so I just take now the derivative of what's in here, which is going to be just 2z. I don't need parentheses because it's only a single term. And now I can do a little bit of cleaning up. The negative 2 can come out here. Negative 2z can come out there. Negative 2z. And then I'm going to take this and drop it back down. Z squared plus 1 to the second power. Now, if you do the quotient rule on that, which I said you could do in the beginning, you should get the same result. All right, let's look at number 15. You have y equals x secant of kx. Now, they don't put parentheses, but I'm going to put it in there just so you can be clear on what they're giving you. All right, so k here is a constant, all right? It's like the number 5 or the number 2 or negative 1. We don't even know what it is. We don't care what it is. So what do we have going on here? Well, we have a product rule, actually, right here. There's a product, okay? So we need to treat this as a product and apply the product rule. So hopefully you're comfortable with that. The derivative of this should be the derivative of the first one times the second one plus the derivative of the second one times the first one. So there's your product rule. The derivative of x is pretty clear, right? It's just 1. But this right here, secant of kx, is a little tricky. I don't even know if you're going to be able to tell the difference in the colors here. Okay? If I try and take the derivative of secant of kx, right? If I'm going to try and take the derivative of this, I need to realize that this is chain rule. You actually do have a function inside of a function because kx is not just x. It's a scalar of x or a scalar multiple of x. So this is an inner function. The outer function is secant. So I'm going to just use that little shortcut. Here's my fist. What is the derivative of secant of a fist? Well, remember the derivative of secant x, right, is secant x tangent x. That's the derivative of secant. So if I say what's the derivative of secant of my fist, it's going to be secant of my fist tangent of my fist. So it's going to be secant of my fist, kx, times tangent of my fist, which is kx. All right, that would take care of the derivative of secant of this. But now chain rule says go inside and take derivative of what's in there. So what's the derivative of kx? And I multiply this. Well, remember, this is like if this were 3x, the derivative would be 3. If it was 5x, the derivative would be 5. So if it's kx, the derivative is k. And that k can come out front. K secant kx tangent kx. That's the derivative of this piece. So now I'm going to come back over here. I'm going to say y prime equals, this was 1 times secant kx plus the derivative of this times x. So here was the derivative of this right here, all of this. But I'm going to take that and I'm going to multiply that times x. So I'm just going to put an x over here. It'll be k, here's the x, and then secant kx, tangent kx. And you could factor out a secant kx, but that's good enough. We're good. Give me just a second here. I kind of like this little board. I really hope the video comes out good. All right, let's look at number 19. Now we're starting to get kind of involved. Number 19, h of t equals t plus 1 to the 2/3 times 2t squared minus 1 cubed. All right, again, we have a product rule. I see a product right here. But I realize also that when I start to go take derivatives of each of those, which I'll need to do for the product rule, each of those are actually compositions. They're chain rules. So this is going to be messy. So let's try this. H prime of t by the product rule should be the derivative of this. So watch the way I write this. It's t plus 1 to the 2/3. I want that derivative times the second one untouched, right? Just leave it alone. Plus this second one, 2t squared minus 1 cubed. Take the derivative of that, and then times the first one untouched, t plus 1 to the 2/3. All right. Now I'm going to need to do some work here. I need to work on this piece right here. And I need to work on this piece right here. So what I'll do is I'll split the board up. Now, this is scratch work. I would normally do this on the side, but I don't have a whole lot of room to work with here. So let's take a look at this one right here. If I want to take derivative of this, I realize I have an inner function and an outer function. So this is like my fist to the 2/3. What's the derivative of my fist to the 2/3? Well, it's 2/3 times my fist, which was t plus 1. And then when I subtract 1 from 2/3, I get negative 1/3. All right, times, now I'm done with the 2/3, go inside, derivative of that is just 1, right? Because the derivative of t is 1, derivative of 1 is 0. So I don't really even need the 1 there. That's a derivative right there. Now on this one, I have the same sort of story. I've got an inner function, outer function. So I have my fist again. My fist to the 3rd power, the derivative of that is 3 times my fist. There's my fist right there. To the 2nd power. And then I've done that part. I go inside, take the derivative, and I tack it on with multiplication. Derivative of this is going to be 4t. And of course, derivative of 1 was 0, so it's only one term. I don't need parentheses. That actually cleans up to be 12t, just moving that out front. And then 2t squared minus 1 squared. Okay, so I'm ready to continue now. And so what I'm going to do is I'm going to come up here, I'm going to erase this. I'm going to put the answer above this. All right, so I have h prime of t equals this right here, which is this. So 2/3 t plus 1 to the negative 1/3. oops, looks terrible, times this piece, untouched, 2t squared minus 1 cubed plus the derivative of this, which we found was 12t times 2t squared minus 1 squared, but then times this one, which is t plus 1 to the 2/3. So there's my derivative. Now I am going to attempt to simplify this a little bit. All right. First thing I'm going to notice is that I have some like terms, right? I have 2t squared minus 1 to the 3rd power, and then in this over here I have 2t squared minus 1 to the 2nd power. So remember, there's two major terms in this. I have common factors. Did I say factors or terms? Okay, I meant to say factors. I have common factors. So let me pull two factors of each of these out. So I can pull out a 2t squared minus 1, and there's two factors in common, right? And then I will have left, once I pull that out, I will have, let's see, this right here, 2/3 t plus 1 to the negative 1/3. And I pulled two factors out, so I still have one factor, 2t squared minus 1, still one of those. So that's all that was left here. Here I have plus. Now I pulled both of these out, so I'm only left with the 12t and then this one, t plus 1 to the 2/3. All right, so that's equal to that. Now let me go a little further. This is 2t squared minus 1 squared times. Now this negative exponent means I can drop it down. So watch the way I write this. I'm going to have 2, which is still up here. Then the 2t squared minus 1, which is still up there, over the 3, which is down on the bottom now. And then I have t plus 1 to the 1/3 down here, plus over here, nothing drops down, so 12t t plus 1 to the 2/3, but I'm going to write it as a fraction because I'm about to try and get a common denominator. So when I get a common denominator, what I'm going to need to do is use this down here. So I'm going to introduce it. So let me get my eraser out. I'm going to squeeze that in there. Here it comes. I'll do it in red. I'm going to multiply the top and the bottom here by 3 t plus 1 to the 1/3 on the top, and then 3, and then t plus 1 to the 1/3 on the bottom. And I can close that off. So that's the same expression. And something nice is going to happen here, because when I multiply this across, right, this right here multiplies with this right here, and since they have the same base, I add the exponents, and 2/3 plus 1/3 is just 1. So this is just going to become t plus 1 to the 1 power on top. So that's really nice. And I need some more room. I think it's a little slower with me using this board. Oh shoot. Get rid of all that. So that equals, I'm just going to rewrite everything, 2t squared minus 1 squared times, now this right here, I'm going to distribute that through. That's going to become 4t squared minus 2, and then plus, because I'm going to have all one denominator, I'm going to put these together, right? So it'll be plus, and then now when I put these two together, I get t plus 1 to the 1st power, but I also get 3 times 12 times t, which is 36t. So So 36t, and then I had that t plus 1 to the first power, right? That's these two. Then all of this over my common denominator, 3 times t plus 1 to the 1/3. I don't think I've mentioned this to you all before, but I'll mention it now. Notice on my t's, I curl them. I do that so that I don't confuse my t's with pluses. Just over time, I kind of realized I need to do that because I kept on making a mistake when I first started out in math where I would confuse my t's and pluses. So I suggest you curl your t's. I also suggest you strike your z's. That way you don't confuse them with 2's. Like if you're going to write the number 2 versus the number z, strike your z's, and that'll help you distinguish between the two. All right. Now, in the numerator, I can clean up a little more. I can distribute this through 36t through both of those. If I get this 36t times t, it's 36t squared, which I can add to 4t squared to give me 40t squared. And then I'll have, what, 36t when I go through there, plus 36t. And then I have a minus 2 up there still. And all of that over my common denominator. You could change that into a cube root if you wanted to. And then out here in front of all of this, 2t squared minus 1 squared. And multiplication here, right there. And you could even go as far as putting this in parentheses and putting that up there with it and just extending your division bar all the way across like that. And that would be correct. So this is number 19. I'm going to look at the answer in the back to see if I got close to what they want. Let me see, what is this, 2.5, number 19. They just left it. What did they do? Wow, okay, that doesn't look anything like what they did. It's close, but they pulled a 2 out. They pulled a 2 out of this. They put it out here, and they just wrote it a little different, but we're at the same place. If you look at it, it looks way different, but it's not. It's just a 2 needs to come out of this. But this is fine. This isn't wrong. All right, interesting. All right, that was number 19. Let's look at 22. These are starting to get interesting. So number 22. How are we doing on time? 38 minutes. This will be my last one for right now. F of s equals square root of s squared plus 1 over s squared plus 4. All right, when you look at that, you might immediately think you have a quotient, which you do, but the problem is the quotient is living inside of a square root function. And so you're going to look at this as a chain rule. You have the inner function is the quotient, the outer function is the square root. So let's apply the chain rule. The derivative of this should be the derivative of the outer function first. So let me get my piece of paper again. All right, so we have the square root of a piece of paper. The derivative of the square root of a piece of paper is 1 over 2 times the square root of the piece of paper. But the paper here is s squared plus 1 over s squared plus 4 times the chain rule, right? So now we're continuing. Now I need to know what the derivative of the inside is. So I actually need to take s squared plus 1 over s squared plus 4, and I need to take its derivative and put it right here. So that's what the chain rule is saying. Here's a derivative of the outer function with the inner function plugged in times the derivative of the inner function. Now the reason why I left it like this is because when we look at that, we should realize that is going to require a quotient rule. So I need to do this on the side, some scratch work. I have s squared plus 1 over s squared plus 4. I'm taking the derivative of this. So quotient rule says it's going to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So the derivative of the top is just 2s times the bottom, s squared plus 4, minus the derivative of the bottom is 2s times the top, s squared plus 1, all over the entire bottom squared, s squared plus 4, that quantity squared. Let's distribute. I have 2s cubed, distribute, plus 8s, distribute, minus 2s cubed, minus 2s, all over my common denominator. Those 2s cubes cancel, and I'm left with just 6s on top, and then this on the bottom. So I can rewrite this now, save myself some time. This right here, I can replace with this. So it was 6s times 6s over s squared plus 4 squared. And I'm not going to leave it like that. I'm going to clean this up. So another thing I'm going to do to help you see how to clean this up is I'm going to rewrite this square root right here. If you ever take the square root of a fraction, you can do the square root of the top and bottom separately. So I can make this root here and then another root right there. That's okay. And then if I have 1 over a fraction, the fraction can flip. So I should get square root of s to the 4th, s squared plus 4 on top. So this fraction came up top. On the bottom, I still have this and the 2. So 2 square root of s squared plus 1, then times this over here, 6s over s squared plus 4 squared. And notice a couple of things. This will become a 3, that's gone. And then this s squared plus 4 to the second power, here's an s squared plus 4 again. I'm going to change the root here to raising it to the 1/2. That's the same thing. And then if I, basically using the exponent properties, if I have something to a power over, same thing to a different power, you subtract the powers. So 1/2 take away 2 is negative 3/2. So where am I at? Where am I at? Where am I at? Clear all this out. Okay, I should have that this is equal to, let me do the numbers for the easy stuff. 3s, I still have a 3s up there. I still had this root right here. But when I do this guy over this guy, I'm left with s squared plus 4 to the negative 3/2. So I have to put that up here. S squared plus 4 to the negative 3/2. And then I can drop it down, right? I can drop that back down, making it a positive exponent. So we should get 3s, and then I have square root of s squared plus 1. And then when I drop that down, it becomes positive, but remember, it's really square root of s squared plus 4, that cubed. And I'm taking the square root of something cubed, so one of those should pop out. I should have 3s over, I'm going to go ahead and pop that thing out and put it out front. S squared plus 4 in parentheses. And then I'll do root, I'll do the s squared plus 4, and then the other root, s squared plus 1. Something like that. Okay, I think that's it for just now. All right, I'm going to go and check and make sure this video looks okay.